we are already recording. We have to turn on the projector in time, but it'll come up. Do want to make a couple of announcements, both of them fairly important, at least two. First, I think I've asked before about student course evaluations. I can't remember if this is the class that said, yeah, they're out there, or the one of the class that said, no, they're not. Okay. Okay. I found out what happened. As one of my other classes said, oh yeah, they're there, and another class said, no, they're not there. We haven't received an email about them. And then finally, I asked enough questions, just sort of randomly, and landed on the right one. What email did you find that told you this? He said, oh, the one that told you about Student Government Association ballots, or something like that. But, oh, you mean student course evaluation wasn't even in the name? They said, nope. Okay, that's why you probably haven't seen it. If you were interested in student government, you may have just looked at that email and either tossed it or ignored it or whatever. If you open that email, you'll see the link that takes you to student course evaluations. Okay, now if you've already deleted it, and if you can find it in the deleted files, go back to it. But if you completely got rid of it, you can't access it through the Lawson State webpage. Does everyone think they can find the email? It has a link. It'll take you right there. Okay. If not, I can walk you through pretty much how to get there through the webpage. It's a little more involved, but it's still not that bad. Okay? So, please, folks, do the student course evaluation. How many have done it already? One. Okay. Please do those. Okay. Now, I understand if you want to wait till the end of the term to do them, just see what you made of that kind of stuff, see what the final was like, that's fine. But I remember, believe it or not, when I was an undergraduate, okay, long time ago, at the end of the term, the brain was basically spent, okay? And I basically was going through the motions, packing up and heading home. Mentally, I was already heading home. And I was not thinking about, oh, I need to go back and do this, okay? So if you're likely to be that mindset, please do them before. Don't put it off and then forget to do them. So please do the student course evaluation. All right, number 2. I got a whole stack of papers here I've been trying to get rid of all term, and I still have some people, believe it or not, I don't think half of you have turned in your research paper yet. If so, it's not much more than half. First quiz, there's a bunch that haven't turned that in. Now, I don't know if we're going to see these people or not, but I don't want to return yours to you and then have them lay eyes on them and come up with a better score than you did, and they've done nothing all term. That just doesn't seem fair to me. So I'm going to return these on Thursday, everyone that I've got. Now, I can't return your research papers. They require us to have samples of student writing periodically, so I have to hang on to those. But your quizzes and your tests, I want to get back to you so you can use them to study for the final. Okay? If so, I'm preaching to the choir here because y'all, I think, are up to date on everything. But for those who aren't here, I hope you're listening, but I doubt if you are. But anyway, if you are, if you haven't turned in a quiz or completed a test or something of that nature by Thursday at the beginning of class or maybe the end of class, then that goes down as a 0. I cannot accept work or have you do makeup work after I return the other papers to the other students. So, please, if you haven't done, if you're behind in any quiz or any test, please get that caught up before Thursday. Let me find Fred, I just know you're in here. There you are. Okay. Good deal. Now, just a quick recap of what I just said. Student course evaluations, have you done that yet? Oh, fantastic. Okay, doubled the number of students who've done it. Okay. And then the I'll be returning everything. So I need everything completed by Thursday morning, 8 o'clock. Okay. You have a what? Okay. You can turn it in by.
I turned it in February.
Did you turn it in email or?
Okay,
I don't have it. Let me check and see. I may have just forgotten to put the grade down, but Jasmine, Gavin, Monica, Kenesha, Madison, Lindsay. No, I do not have it. I keep them all right here. Do you still have it on the disk or something? Huh? Okay, well, I do not have it. I'll just check and see if it got in my trig class, but I can't imagine it did because I go through those. It would stand out if it was there because none of them have turned it in. I got to really get on them. They've turned in paper topics, but no papers, so no, it's not back there either. This is my stack, and it's not there. Okay, so please have now I can't return your research papers to you because they periodically ask for samples of student writing, but everything else gets returned. But Thursday is the last day to get it to me because after Thursday you start losing points if I don't have your research paper. All right, so we're going to wrap up 2.5 today and do what we're going to do in 2.6. And then we will be, if we have time, and probably on Thursday we'll get a little bit into Chapter 3. I just want to introduce you to that and get that knocked out. Okay? So, I think I marked everybody here. 1, 2, 3, 4, 5, 6, 7, 8, 2, 4, 6, 7, yeah. All right. Where we are in the text, any questions? Any math questions or otherwise?
What section is
This
this?
is 2.5. Okay?
And one more question. When is our final? Is it next Tuesday?
Tuesday. Yeah. Tuesday at 8 o'clock. Okay? And you remember, for the final, you have an hour and 50 minutes, not an hour and 15 minutes. So you have basically 2 hours, and you can have as much time as you need. I will, and again, I mentioned this to people here earlier, the final will consist of 2 parts. The first will be a Chapter 2 test over what we covered in Chapter 2. If we cover anything in Chapter 3, there may be 1 or 2 short questions on that. I may not know that in time to when I'm making it out, so we'll see. But then the second part will be comprehensive on Chapters 1 and 2. No, it's just like your first test. It's and the quizzes. Fill in the blank, right? You know, working problems, basically. Okay. All right. Any other questions? Okay. Now, example 7 that's up here on the board now, we had already done, but I think the reason it's up here is that example 8 and 9 were not on their slide set. So let's do example 9. We've already done 8. Let's do example 9. Here comes one more. 2 more. All right. Jasmine? Is that right? Huh? Kiara. Okay. And? I'm sorry? Kayla, I'm trying to find it. Yeah, Kayla. Yeah. Mayfield. All right. So let me go over quickly what I've just been saying a couple times with everybody else. Number 1, student course evaluations. Have you done those yet? Please do those as soon as you can. You know how to get to the link? Okay. We'll do those as soon as you can. And then number 2, On Thursday, I'll be returning everything that's been turned in except the research papers. Now, the research papers are due by Thursday. You can get them to me sooner, I'd appreciate it. But they're due by Thursday. After Thursday, they start losing points. And then all your quizzes and tests you have to have completed by Thursday morning, because I'll be returning those to you, and you cannot take one after I return them to other people. Okay, so Melvin's here. So please get everything caught up before Thursday morning. Okay, and then the test will be next Tuesday, a week from today, 8 to 9:50, and it'll consist of two parts. The first part will be the Chapter 2 test, and the second part will be the comprehensive part. Okay. So, any questions? Any other questions before we move on? All right. It says example 7 we've already done is 7 and 8, but here's what we have. Example, well, let me get my pen set up. All right, here's Madison. Taylor, I'm sorry. Madison's your other name, but Taylor. Okay. Here we have a function. Okay. F of x is equal to x to the 5th plus x cubed plus 2x squared minus 12x plus 8. All right, there's your function, f of x. It says write this as a product of linear factors and list all the zeros of the function. Okay? Now I'm going to amend that slightly. I'll say linear factors or irreducible quadratic factors, because we're not going to do that much with the complex factors. So we'll just limit it to those. And then it says, and list all the zeros of the function. We'll say all the real zeros of the function. So there's your task. There's your function. Factor it as completely as you can and list all the real zeros of that function. This will be a type of question like you might see on the test or the final. Where would you begin? What would be your approach? Are you guaranteed there are any real zeros? Could these have only complex zeros? Deafening silence. Okay. What you think? Are you guaranteed there's at least one real zero, or could all these zeros be complex? Well, certainly they're all complex, because all real numbers are complex. Complex with imaginary parts. Any ideas? Okay. There's two ways you can tell there's at least one real zero here. And the first is one of the first things we did with these functions, higher order functions. Leading term test. What does that tell you? Say again? The degree is 5. What does that tell you? At most 5 zeros, but they could be real or they could be imaginary, have imaginary components to them. Okay, so that doesn't guarantee, but you could have up to 5 zeros. What else does that tell you? The end behavior. What does that tell you about the end behavior of that function? As x gets very large negatively, where's the function heading? Negatively. Down. Because negative number raised to the odd power is going to be negative. How about if it's a very large positive number? Up. It's got to. So now you have a function doing like this. It's got to cross the x-axis somewhere. There's no way around it. Okay? So we know it has at least one real zero. It may have 2, it may have 3, it may have 4. Let's see, let me back up. Counting multiplicity, it's got to have 1, 3, or all 5. Now, the rest of it goes into the second thing I was going to point out. Notice all these coefficients. They're all real numbers. Not only that, they're all integers, okay? But they're all real numbers, and if all the coefficients are real numbers, then if you have an imaginary root, you might say, a complex root with imaginary components in it, they always come in conjugate pairs. So if you have any complex numbers in this one with imaginary parts, it's either going to be 2 or 4. You can't have 1 or 3 or 5, okay? So it's got to be 2 or 4. So you're either going to have just the one real root, you could have 3 real roots, or all 5 of them could be real. If you don't have real roots, they're imaginary or complex with imaginary components, and they always come in conjugate pairs. Yeah, Brianna, I see. You almost threw me, but okay. All right. So we know we're going to have at least one factor that is going to have a real root. Okay? And the other two you can split up, even if they're complex, they'll be quadratic factors. Okay? So where do we begin? We know that much, but how do we find these things? Now we go back to the fact that these coefficients are not just real numbers, but they're integers. And if they're integers, then there's a test we can do to come up with possible roots. What's that test called? Rational zeros test. Very good. And how does that go? You're guaranteed, if you have any rational zeros, they're going to be in the form P over Q, where P is what? All the possible factors of the constant term. No, the denominator is the 1, okay, of the constant term. And what are the possible factors of that? All of them. Plus or minus 1. Plus or minus 2, plus or minus 4, plus or minus 8. Perfect. And then what is your denominator? Possibilities there. The factors of your leading coefficient. What is your leading coefficient? 1. So its only factor is plus or minus 1. That makes this really easy. There aren't any fractional forms. They're all going to be those numerators, okay? So since we know all our rational zeros are either going to be plus or minus 1, 2, 4, or 8, that still gives us a possibility of 8 different numbers. But remember, in counting up those 5 possible roots, you could have repeated roots in there. So let's see. Where do you want to begin? 1, the easiest one to do. How can you tell if 1's a 0 of that or not? Just plug it in and you'll see it's your coefficients. So let's add up the coefficients. 1 and 1 is, and 2 is. Okay, 1 and 1 is 2, and 2 and 2, 2 and 2 is 4, and 4 and 8 is 12, and there you have a minus 12. Yes, we know already that one of those zeros is 1. So what do we do with that fact? So they asked for, find all the zeros of the function, we found 1. The zeros, x equal 1. We got 1. What do we do with that? What's the next step? Anybody? Okay? Actually, synthetic division. Factoring is like division, but this is such a big number, I can't factor that. It's too many terms, 1, 2, 3, 4, 5 terms. You can't do factoring by grouping. So the best way to do it is by division. We know it's going to be a 0 already, but what do we go into? 1, 0, excellent. When you're missing a term here, like you're missing the 4th degree term, you have to put a 0 in. Next, 1, 2, negative 12, 8. Okay? Now, I always stop and count. 1, 2, 3, 4, 5, 6 numbers there. 5 is your degree. Always got to be one more than that. So, yeah, we got it not. Then we skip a line, draw a line. Bring down the 1. And then what? Multiply, and that gives you 1. Then you, and that gives you, and 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 then you, that gives you, then you multiply, and that gives you, okay, negative 8, and then you multiply, you get negative 8, 0. Ding, ding, ding. We knew they were going to happen because we already knew that was a 0. Your remainder has to be 0 if that's a factor, okay? Oh, and by the way, since we know that x equals 1's a 0, what are your factors? Give me at least one, the one that corresponds to that. X, no, minus 1. Because if you add 1 to both sides, you get x equal 1. Okay? So it has to be a minus there. Okay? Now, where do we go next? Okay? Let's do 1 again. Remember, you could have repeated roots, multiple roots. Now, I'm going to do 1 fairly easily because we'll do it the same way. These are the coefficients of the next polynomial down. That'll be a 4th degree polynomial. Let's add these again. 1 and 1 is, and 2 is, and 4 is, and 8 is, negative 8 is, 8 and negative 8 is, 0. So there's another. 1 is a repeated root. Okay? So let's do 1 again. And skip a line, draw a line. Go for it. 1, 1, 2, 2, 4, 8, negative 8, 0. Ding, ding, ding. We knew that already, but here we've confirmed it as Kaylee comes in. Okay. Let me say this again so everybody hears it. Student course evaluations have been open probably for a couple weeks. About most of the students I've talked with didn't know they were open because they were open in the email that came out about voting for student government officers. The title of the email wasn't student course evaluation. It was something to do with voting for student government. Okay? So therefore, go to that email if you haven't deleted it and find the link for the SMART evals and do your student course evaluation. Please get those done. Number 2, and if you've already deleted that email, I can show you another way to get there. It's a little more complicated, but that way it's pretty easy. Just click on the link and you're there. Okay, number 2, research papers are due by Thursday. I'd like them sooner, but they're definitely due by Thursday. Anything turned in after Thursday, I will accept, but you'll lose points. Okay? So please get those in. That counts as a quiz score that cannot be dropped. You don't want a 0 for a quiz score. That's going to pull down your whole average. Okay? So get your research papers in before Thursday, by Thursday. Number 2, Thursday morning, I'll be returning all the work that has been turned in, except for research papers. I have to hang on to samples of student writing they ask for periodically. So I can't return those, but I can return your quizzes and tests. Therefore, if you haven't completed a quiz or a test You need to get that done before Thursday morning. You have today and you have tomorrow. Let me give you my office hours. I meant to do that earlier in case some of you have forgotten. I don't have many because I picked up 2 second mini-term courses and they take a lot of time. So on today, 10:45 until 1:15. That's it, folks. 10:45 till 1:15. Okay? Now, I did not bring my lunch today, so I'll be going to the cafeteria to get it, but I'll come back to my office and eat it there. So except for those few minutes, I'll be pretty close to the office. Okay? Then tomorrow, Wednesday, 7:45 until 9:30. Okay? It's the first little block of time. And the second block is between 11:15 and 2. Okay? 11:15 and 2. After 2, I'm teaching a class, heading to the Birmingham campus and teaching another class. So have almost no office hours after 2 o'clock. So that's all. So if you have a test to make up, a quiz to make up, or turn in, get it to me then. Now, if it's just turning something in and you can't find me or I'm in class, you can take it down to my office, 265, slide it under my door. I found 3 things there this morning. So it's perfectly okay to do that. Okay. Now, I just want to get that out. So here we found a second 0, okay? So x equal 1 and x equal 1. That makes one of the factors x minus 1 squared, because it's x minus 1 times x minus 1. So we have 2 factors that are x minus 1. Now, you think you want to go to work again? No, you add these coefficients, there's no way you're going to get 0, they're all positive. In fact, the next test we're going to look at deals with these remainders are all positive numbers. So if that won't work, now we might try a negative 1. Now there's no easy test for this, you just do your division. So let's try it. Guess what though? We know we've got at least one more real 0, because you can only have an even number of complex zeros with imaginary parts, because they come in conjugate pairs. So we got 2 reals, that leaves 3 unknown, so at least one of those 3 has to be real. Maybe all 3 of them, but at least one has to be real. So let's proceed. Now this is only going to give us rationals, but let's see what we can find. Let's do a minus 1 into that. And what's the procedure? You tell me. Drop the 1. And that gives you negative 1. And that gives you. And then. And what you get? And you get 3. And you get negative 3. No way you're going to get a 0 there, is there? Okay. Now I'm going to tell you something now that we're going to do in just a few minutes, just to save us some time. I said, whenever all these turn out to be positive, don't try any more positive numbers, because they're just going to get bigger and bigger and bigger. Okay? You'll never get a 0. So we're going to ignore all the positive numbers and go with the negatives. So the next one we're going to try is negative 2. Okay? So let me erase these and that. And let's try negative 2. Okay, I already dropped down the 1. This gives us negative 2. This gives us 0. This gives us. This gives you 4. This gives you negative 8. Ding, ding, ding. Here we have another 0. So we also have a 0 of x equal negative 2, which would make the factor what? Second, x plus 2. Perfect. Okay? Now, what does this represent for us? That started off a 5th order polynomial. This went down to a 4th, a 3rd. Yeah, it's a quadratic. Okay? Once you get to quadratic, stop doing synthetic division. Deal with the quadratic, because we know how to deal with those. What is that? What does that represent? X squared plus 4 and set it equal to 0. And guess what, team? No real factors for that one at all. Okay? With Tadarius here. All right. Now, I'll say this quickly. I've said it every time someone's come in. Student course evaluations, please get those done soon. Have you seen the email? They gave you the link for it? For student course evaluation? Okay, good. Please do those if you haven't already. Number 2, your research papers and everything else is due by Thursday. Okay? You've had all term to do the research paper. Only about half of you have turned in one. So please get those in to me today, tomorrow, or before class on Thursday. Okay? Thursday morning, I'll be returning all quizzes and all tests that I've already returned to you. I don't think I've returned any because some people have not turned in anything. So please get those turned in by Thursday. Once I return papers to you folks on Thursday morning, no one can make up anything else. Okay? You get zeros for those, and then you're pretty much sunk. Okay? So please get everything completed before Thursday morning because I will be returning all those papers to you Thursday. Lastly, the final exam will be Tuesday morning, 1 week from today, 8 to 9:50. You have almost 2 hours for that, and the first part of that will be the Chapter 2 test, and the second part will be the comprehensive part. Okay? And you will, they'll be short and easily done in 2 hours. Okay? So, what does this tell us? Can you think of any real number that you square and add it to 4, you're going to get 0? No way. The only one is going to be plus or minus 2i. So that's complex with imaginary parts. So guess what? We're going to leave this as a factor, an irreducible quadratic factor. So there we have our 3 factors. Actually 4 factors, and 2 of them, 1 of them is repeated. And we have our 3 real zeros. Okay? So your factors are, okay, those x minus 1 times x minus 1 times x plus 2 times x squared plus 4 will give you the original function. Those are the factors, and here are the real zeros. The other 2 zeros are complex with imaginary parts, and we know what they are, plus or minus 2i. You can write that down if you want to, but I'm looking for the reals. Okay? And you'll see they go through the same procedure and get the same factorization, only they do the imaginary numbers in it. I didn't. And they do the same zeros with imaginary zeros. I didn't. There is a checkpoint there, well worth your effort to do that. All right, any questions on that?
So on the test, you'll be asking for the zeros and the factors?
Possibly. Sometimes it'll ask for both, sometimes one or the other. Okay? But expect both. If you got one, you got the other. I mean, yeah. The thing is, the x squared plus 4, that's a factor without a real zero with it. But it's a quadratic factor. Irreducible quadratic factor. Okay. And this is Monica. Okay. I'll go through this quickly again. Student course evaluations. Do you know how to access those? Student course evaluation? Okay. Have you already done it? No. Okay. Please get it done as soon as you can. You can wait till you see your final grades if you want to, but please don't forget it. I know when I was an undergraduate, if I waited that long, the odds of me remembering to do a student course evaluation were close to 0. Back then, we were required to do them in class. We don't do that anymore. It's all online. Just get it done. Number 2, the research papers, if you haven't already turned it in, I think you have, due by Thursday. That's the last day before you start losing points. And then all your other work that's done, your quizzes and tests, if you haven't completed those, they have to be done before Thursday morning as well. Because Thursday morning, I'll be returning all the papers except for the research papers. I have to keep those for samples for student writing. because they ask for that periodically. But the other quizzes and tests, I want to get back to you so you'll have the time for your final, to study for the final. Okay? And I will be returning the others to you. Once I've returned those, I can't accept any back. Okay? So please get them in by Thursday. I'm preaching to the choir pretty much here because it's the people who are not here typically who haven't turned in stuff. Okay. Other tests for zeros of polynomials. Now, y'all already said this for me. Oh, man. You know that nth degree polynomial function can have at most, as Kendrick said, n real zeros. Okay? Of course, many nth degree polynomials do not have that many real zeros. Okay, some of them may be complex, like this one. That has no real zeros. It's a second degree polynomial, no real zeros. The two zeros it does have are both complex. Okay? This one over here, x cubed plus 1, only has one real zero. Okay? It's got to have one because it's a cubic function. It's going to cross the x-axis somewhere. We know it's at -1 because -1 cubed plus 1 is 0. So -1 is your only real zero. The other two are complex. Okay? So, we know how many we may get. We just don't know if they're real or complex. The following theorem is called Descartes' rule of signs. Now, Descartes has always been a potential paper topic. Incredible mathematical mind, but not just mathematical. He was a great philosopher as well. Many people believe that some of his philosophical ideas, he was French, by the way, made their way into our Declaration of Independence and Constitution, because he was quite a thinker. Okay? In fact, one of his most famous quotes, I don't know if you've ever heard it, you may not know who it came from, he was quoted as saying, "I think, therefore I am." In other words, he said, I know I exist because I have a mind to think. Otherwise, I could be a rock. You know, I would not exist as a person. I would exist as an inanimate object. So therefore, Descartes' rule of signs, he came up with a real decent way of telling you whether to go on or not. Sheds more light on the number of real zeros of a polynomial. Here's what it is. A little involved, but once you do it, it's pretty simple. Here's your function, f of x. A sub n, that's just a coefficient for the leading term. That this n is just an indicator that it's a coefficient for the leading term. X raised to the nth power, that's an important part of the problem. Okay? Chris is here. All right. Now, I guess I need to say it one more time. You know about student course evaluations? Already done them? All right. Oh, no. Okay. But you know how to access them. Okay. Okay. Please get those done as soon as you can. Number 2, your research papers are due by Thursday. Anything after Thursday is going to be losing points. I will accept them, but they'll be losing points. Also, Thursday morning, beginning of class or somewhere into class, I'll be returning all the papers that you've turned in. The quizzes, the tests, everything, except the research papers. I have to hang on to those. Okay? So therefore, I will need that. And if you have anything that hasn't been turned in by then, that's a 0. Or if you have turned in a partial, you get that partial score. Okay? You don't want that to happen. Please get everything done by Thursday because I will be returning. Once I return the papers, I cannot receive any more in. Okay, so let's get back to this. Oh, and the final exam will be Tuesday, 1 week from today, starting at 8 o'clock in the morning, believe it or not. Okay. And it'll be in 2 parts. The first part, 1 hour test, will be chapter 2, and then the second part will be comprehensive on 1 and 2. Okay. I think you'll find the 2 fairly easy tests. Okay, much shorter than the original. Okay, so here we have our function. The coefficients and then the exponent raised to that power. All right. Here's J-Lo, right? All right, good. Mostly J-Lo anyway, okay. All right, let me go over it again. You know about student course evaluations? Yes. Have you already done them? All right, good deal, okay. Secondly, your research papers are due by Thursday. I can't remember if you've already turned yours in, okay? And all your other work has to be in by Thursday because I'm going to return it all on Thursday. Once I've returned the quizzes and tests, I can't receive any late work. Once I do that. I wish I had gotten rid of most of them already, but there's several that I don't have. Okay, so here's your polynomial. Oh yeah, the final exam will be next Tuesday, 1 week from today, 8 o'clock in the morning, and it will be, the first part will be Chapter 2 test, the second part will be the comprehensive part. Okay, 2 1-hour tests. All right, so here's your polynomial, counting all the way down there, okay? Let this be a polynomial with real coefficients. We aren't going to have any imaginary or complex coefficients in there. Real coefficients, as long as a sub 0 is not 0. Now, usually they say a sub n. It can't be 0 either, but now also a sub 0 won't be 0. Okay? There's a reason for that, but we won't go into it now. Here's what the Cart's rule of sign says. The number of positive real zeros of this function f is either equal to the number of variations in sign of f or less than that number by an even integer. Okay? So give me a number for n. Make up a number. 4. Okay. So if n is equal to 4, that means you could have up to 4 real zeros, right? Okay. Now you count the number of variations in sign. If n is 4, you have 5 terms. 1, 2, 3, 4, 1, 2, 3, 4, 5. Okay, 5 terms. This will be cubed and this will be fourth, using the terms that are there. Now you look at your coefficients. If the first one's positive, the second one's negative, that's a variation in sign. If the next one's negative, that's not a variation in sign. But if the next one is positive, that is a variation. So you count your variations in signs. If you have none, there are no real positive zeros for that function. If there's 1, there's only 1. But there's got to be 1. If there's 2, there's either 2 positive real zeros or no positive real zeros, because you subtract by an even integer. If there are 3 variations in signs, then you have either 3 or 1 positive real zeros. If there are 4 variations in signs, you have either 2, 4, or 2. Okay? And that's all, because that can't have more than 4. Okay? Now, how about negative real zeros? What we do then, the number of negative real zeros, is either equal to or the number of variations of sign of f of x of minus x. So what we do then, you gave me n equal 4. So if you put a minus x in here, minus x in here, negative 4 to the fourth, a negative number, a negative x to the fourth power is going to be positive x. So that doesn't vary in sign. But the third one will, because the negative x here changes the sign. The second, the x squared, will not change its sign. This one will change its sign, and that stays the same. So once you change the signs of the odd terms, then you count your variation in signs again, and that gives you the number of negative real zeros, or subtract 2 from it. So if you had no negative real, no changes in sign, once you put in a negative x there, you have no negative real zeros. If you have 1, you have to have the 1. 2, you have either 2 or 0, 3, 3 or 1, and 4, 4 or 2. Or 0, 4, 2 or 0. Okay. So variation in sign means that 2 consecutive coefficients have opposite signs. Now that's a lot of blah, blah, blah. Less x, well, no, there's more blah, blah, blah. Okay, when using the Cart's rule of sign, a 0 of multiplicity k should be counted as k zeros. Remember that last one? We had x equal 1 and x equal 1. That's 2 zeros, even though it's the same number. Okay? For instance, this polynomial here has 2 variations in, oh yeah, I should have asked you this. How many variations in sign? Plus to minus is 1, and minus plus is another. 2 variations in sign. It's a third degree polynomial, so how many positive real zeros can it have? 2 or 0. Always subtract 2 as well. Okay? keep subtracting 2 until you get down to 0 negative number. Okay? So it has either 2 positive real zeros or no positive real zeros. Okay, the next thing we're going to do is put a negative x in here. What will that become? Negative. This will become positive, and that stays positive. So how many variations in sign do you have there? 1, negative to positive, okay? And so it has 1, and it has to have 1 real negative 0. So 2 or no positive real zeros, 1 negative real 0. There's your 3 real zeros, 3 zeros, okay? Now, what they did, they managed to factor it somewhere. They didn't show you how, but I would suggest it. Do a rational zeros test, okay? And when you did a 1 here, 1 minus 3 is minus 2 plus 2 is 0, so you know x equal 1 is a 0. And then you try it again, and you get, there's your 2 positive real zeros, there's your 1 negative real zero. You can see that those 2 positive real zeros, you count them twice because it has a multiplicity of 2, even though it's the same number. All right. So here we have it. Now this is just saying determine the possible numbers of positive and negative real zeros for this function. Okay, now what's required? Real coefficients. You can't have any complex coefficients. These have all reals, and they're all integers as well. So that means not only can we use the partial signs because they're real, but you can also use rational zeros tests because they're integral. Okay? So, what's the possible number of positive real zeros? 1, that's a plus to minus, 2, 3. 3 or 1 positive real 0. Okay? And this is a third degree polynomial, right? Okay? We'll see this. What's our next step? That gives you the number of positive real zeros. How do we do negative? Consider alpha of negative x. Okay? What would that first one become? First term. Negative 3x cubed. How about the second term? And it stays negative because when you square a negative x, it's still x squared. So that doesn't change the sign. Minus 5x squared. Minus 6x, so I'll put a minus x in there, you change the sign. And then, second, minus 4. So it has how many negative real zeros? None. 0 negative real zeros. 0 negative real zeros. None. So when you do your rational zeros test, that would be all the possible factors of 4 divided by all the possible factors of 3. You did all those plus and minuses. Leave off the minuses. You know by the Descartes rule of sign, you don't have any negative real zeros. So only look at the positives. So you see you cut your work in half in your rational zeros test because you knew there's no negative real zeros. See how it's helpful? And also, if there had been 1, but only 1, once you found that 1 negative real zero, don't do any more negatives because it can't be any more. Okay? So you get the idea. That's all they're asking for here. Okay. Now, what they did was graph the function. Now, I don't know, I imagine they're going to show it. But the next thing I would do, we're not going to find the zeros. We could, but the easy one would be 1. I always do this just to see if it is 1. 3 minus 5 is? Negative 2 plus 6 is? And negative 4 is 0. You know x equal 1 is 0. So there's your 1. You could have 2 more or no more. And they show in the graph that it's the 1 and the only 1. Okay. There is a checkpoint. Please do the checkpoint. Okay. I'm going to clear this. Are there any questions before I clear it? Okay. The original polynomial has 3 variations in sign, so therefore it either has 3 or 1, what? Positive real zeros. Okay? Now we do the f of minus x, and they write it all out. 3 times minus x cubed minus 5 times minus x squared plus 6 times minus x minus 4. Well, negative x cubed will be negative x cubed. So that changes the sign and makes it the minus 3x cubed. The negative x squared becomes x squared. That doesn't change the sign of the minus 5. The negative x times positive 6 does make it a minus 6, and then minus 4 stays minus 4, but it has now no variations in sign, so you know it has no negative real zeros. So don't waste any time doing synthetic division with negative numbers. It's not going to happen. Okay, so from Descartes' rule of signs, the polynomial, this one, has either 3 positive real zeros or 1 positive real zero, and definitely has no negative real zeros. Here is the graph of it, and you see there's your 1 positive real zero. The other 2 are complex. You don't know that for certain, but what we do know is that tells you that. So don't go looking for any negatives. Not going to be. And just judging from that, it's going up and never coming down again. Okay. Another test for zeros of polynomial functions is related to the sign pattern in the last row of synthetic division array. This is the one I already referred to. This test can give you an upper or lower bound of the real zeros of F. Okay? A real number C, any real number C, is an upper bound of the real zeros of F when no zeros are greater than C. That's called an upper bound. Similarly, C is a lower bound when no real zeros of F are less than C. Okay? And remember when we listed them out there in the rational zeros thing? If you run into one that's an upper bound, forget the ones greater than that. If you run into one that's a lower bound, forget the ones less than that. Okay? So here's the upper and lower bound rules. I hurt my knee over the weekend, and it's fine when I can move around on it. When I sit too long, it hurts like crazy to get up. Okay, the upper and lower bound rules. If f of x is a polynomial function with real coefficients, just like the Descartes rule of signs, and a positive leading coefficient, okay, there's the requirement, a positive leading coefficient. Suppose f of x is divided by x minus c using synthetic division. So you got a c on the outside, there's coefficients on the inside. Okay? Now, if that c is positive, greater than 0, and then every number in the last row is either positive or 0, then c is an upper bound. Because when you get all positive numbers down to that last row, you can keep doing your synthetic division, the numbers go bigger and bigger and bigger. You'll never get a 0. So that makes it an upper bound if all these numbers are either positive or 0. However, if c itself is less than 0, a negative number, and the numbers in the last row are alternately positive and negative, 0 counts either as positive or negative, however you want to, then c is a lower bound. So if the signs alternate in that last row, then that's a lower bound, if that c is negative to begin with. And again, sort of a lot of blah, blah, blah. Whoa, they skipped the examples with that. So let's see, we did the Descartes rule of sign 10. Let's do 11. Okay. Let's do 11. We did do 10, didn't we? Yeah, the examples on the slide are one behind the examples in the book, because we had done one last time. Okay, find all the real zeros of this function. F of x is equal to 6x cubed minus 4x squared plus 3x minus 2. Okay? Find all the real zeros. Now that's all they tell us. Find all the real zeros. What would you do first? And the order really doesn't matter too much. A little bit maybe to help save yourself some work. But what would be one of the first things you would do? What's the obvious thing you can do right now? Just looking at it. A little louder? Yeah, Descartes' rule of signs. Okay? How many positive real zeros do you think you might have? 1, 2, 3. 3 or 1. Positive. I can't write positive without wanting to write a plus or minus under it. Okay. Positive real zeros. Okay? Then, next step for that is alpha of negative x will be negative 6x cubed minus 4x squared minus 3x minus 2. So what does that tell you? 0. No negative real zeros, just like the last one. Okay? So, that's already shortened your work for the next step, which is rational zeros test. The reason you can use rational zeros test is all those coefficients are integers. To do Descartes' rule of signs, they just got to be real numbers. Okay? But to do rational zeros, they have to be integers. So, we'll do the rational integers test. What are your possible, goodness gracious, possible rational zeros? P over Q, where P is what? All the possible zeros of, I want to say plus or minus 1. But guess what? Let's leave off the minuses. 1 or 2. Okay? How about your denominator? Okay, 1, 2, 3, and 6. Notice I left off the minuses. You can't have any real zeros that are negative. Descartes' rule of signs shows you that. So let's list out the ones we're going to consider. Okay, I like to do the whole numbers first. So 1 and 2, that's easy. That's when they divide by 1. Now let's divide each of those by 2. Well, 1 over 2 would be 1/2. 2 over 2 is 1. Well, we've already done 1, so you don't have to list it again. Then go over 3. That would be 1/3 and 2/3. You see what I'm doing? And then we'll do the last one, 1 over 6. 2 over 6, which is 1/3, so we don't have to do that. So there are all our possible real zeros, possible rational zeros for this polynomial. Which one you want to start with? 1. And 1's so easy, let's just add our coefficients. And here's how I really like to do them. I add the positives. I did the other way. Add the positives. 6 and 3 is 9. Negative 4 and negative 2 is negative 6. That does not add to 0. Who does? Okay? So don't mess with 1. You throw that one out. Okay? So which one would you want to start with next? Yeah, let's do 2. Okay? And what do you put down here then? 6, you said? Negative 4, 3, negative 2. Let's count those. 4, maximum exponent is 3. That's good. And then you skip a line, draw a line, and do what? 6. And that gives you 12. 8, 16, 19, 38. I'm going to write it out for one reason, and then when you add, you get 36. Notice here, all these are positive, so don't go beyond 2. Guess what? We don't have any rational zeros beyond 2, but not even irrational zeros. You will not have any real zeros beyond 2, so we're going to give up 2. So now I guess we have to go back and do our halves and thirds and whatever. So let's go back and erase this, 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 that, and that. Okay? And I'm going to make that divider now not 2, but 1/2. Okay? I was really lazy. Okay? Where do you go from here? And what you get? 3. -1. And what you get? -1/2. Ooh boy. How many halves is 3? No? If you had 3 pieces and cut them in half, how many half pieces you got? 6. Think in terms of food. I always like food, okay? So this will be 6 halves. And 6 halves minus 1/2 is 5 halves. And let's just say we're not going to get that, right? Okay? Yeah, you're not going to get it. But you do know that it alternates signs, so, and this is a positive number, so they're probably still, 1/2 is not your upper bound. Okay? So we'll try the others. But we know that's not going to give you a 0. So we're going to erase that and try 1/3. Okay, and see what we get. Okay? What you get to begin with. And what you get? Say again? No, not 3. 2. Okay? 1/3 of 6 is 2. 6/3 is 2. Okay? And then you do what? And what you get? -2. Then you get -2/3. 2/3. Okay? Now, how many thirds is 3? Say again? Okay. One more time? Yeah. You said 6? Okay, now. All right. You have 3 pieces. Cut them into thirds. How many thirds of a pizza do you have? No, you don't. Goodness, you ate 3. Okay. You have thirds of a pizza. You have 3 pizzas. Cut them into thirds. This one you're going to have 3. That one you're going to have 3. And that one you're going to have 3. Say again? 9/3. Yeah, 9/3 is 3, isn't it? 9/3 is 3. Okay? And when you subtract 2/3 from 9/3, you get 7/3, and there's no way that's going to give you a -2. But your signs are still alternating. So that's not a greatest upper bound. So let's try 2/3. That one's not going to work, but let's try 2/3. Boy, I don't like these fractions very much. 2/3. And what do you get when you multiply? 2/3 of 6 is 1. It's, say again? It's 4, okay. I couldn't hear what you said, and now I realize that's what you said. And then you add, and you get 0. And you get, and you get, and then you get, say again? 2/3 times 3 is 2. Ding, ding, ding. You found the 0. X equal 2/3. Now what else does this tell you? We have no sign changes here, So don't go any higher. Well, we'd already eliminated 2. If we'd have done this one first, we wouldn't have even messed with 2. 2/3 is the greatest upper bound. Okay? So there is a 0. Positive 0. You know you don't have any negative zeros. You know you can't go any higher. This looks like the one and only. Okay? What do the problems say? Find all the real zeros of that. Here you have it. X equal 2/3. That's your only real zero. Now, how else can you confirm that? Plug in what this is. 6x squared plus 3. Set that equal to 0. No real numbers. Okay? Because you can't square a number, any number, multiply it by a positive number. This is going to be positive. Multiply it by a positive number, be positive. Add a positive number, it's going to be positive. No way it's going to be 0. None whatsoever. There's your one and only one real 0. Okay. So, any questions on that? Oh, they do show a graph, but that's in your book. They don't show it on the slides. It looks a lot like that one, but it's a little different. Okay? All right, we had already done that and that. Now we're ready for application. I have a feeling we're not going to have time to do the application. So we'll pick up and go from that next time. So we will get to, and this is the last thing in the chapter. Homework exercises here will include any of the odds, any of the odds 9 through 13. They're all at calcchat.com, 9's at CalcView. Do either 15 or 17 or both. They're both at CalcChat. Do any of the odds 19 through 27. They're all at CalcChat. 25's at CalcView. Do either 29 or 31 or both. They're both at CalcChat. 29's at CalcView. Do either 33 or 35. They're both at CalcChat. 37 or 39. They're both at CalcChat. Any of the odds 41 to 45. They're all at CalcChat, but 43's at CalcView. Either 47 or 49. They're both at CalcChat. 49's at CalcView. 51 or 53 or both. They're at CalcChat. Any of the odds 55 to 59, they're all at CalcChat. 55's at CalcView. Do any of the odds 61 to 71, they're all at CalcChat. 69's at CalcView. Do any of the odds 73 through 77, they're all at CalcChat. Do any of the odds 79 to 85, they're all at CalcChat. 83's at CalcView. Do either 87 or 89, they're both at CalcChat. Do either 91 or 93, they're both at CalcChat. Do either 95 or 97. Say again, they're both at CalcChat. And then rational and irrational zeros, you can take a look at that if you'd like. That's 99 or 101. They're both at CalcChat. We'll wait and do the geometry and other application problems until after we do that last. All right. So Thursday, get everything done by Thursday. Research paper, quizzes, tests, everything. And good deal. Thank you.
Oh, mistake.
Okay, if you like. All right, good deal. Thank you. Good deal. Thanks. Good deal. All right. Yeah, you haven't done the first test, have you? When are you going to do that?
Whenever you're ready.
When are you ready?
I'm doing today.
Right now? Or later?
You say you got 2:45 to 1:45?
Okay, today, my office hours are 10:45 to 1:15. But if you wanted to start it now, I've got another class. I can just find another room for you. You can work on it now. If you want to wait till later, 10:45 to 1:15. My next class starts at 9:30.
This right now, 9:30?
Yeah, that's what I said. 10:45 is when I'm out of that class, and then until 1:15 when my third class starts. And that goes until 6 o'clock or 5:45. It's a mini term with a lab. Huh? Now? Okay.
What about test 2?
Test 2 will be with the final. I said that several times today. The final exam will be 2 parts, second test and then the comprehensive.
But that's the thing, I got a problem. On Friday, I'm getting surgery on my throat.
What's that?
On Friday, I'm getting surgery on my throat.
Really?
Yeah.
Okay. Will you be back?
That's the thing.
What's that?
I tried to wait till after my final, I couldn't wait no more.
Okay.
So
what does that mean? Are you going to be back after finals or not? You're not?
no.
Okay. So that means you've got to take your final by Thursday.
Yeah.
Okay. So what you'll need to do is then after class Thursday, just like now, you'll need to take the chapter 2 test and then take the final exam. Okay? All right. Means I got to get those run off by Thursday then. All right. But y'all are wanting to take your test 2 right now, right?
Just one.
Oh, test 1. Sorry. No. Test 2 on the brain.
Hey, what are these pencils?
Okay. Here are the tests. Do you need graph paper?
Yes. You got some scratch paper?
What's that?
Scratch paper?
If you got it, you can use it, yeah.
Well, I'm saying like, I mean,
What's that?
I said if you
Okay, I can get some in the office there, but hang on a minute. Let me find you some graph paper first. Okay, let's have you need graph paper. I think there's just one to graph, but you can get
Thank you.
one. All right. Now, all I got is unlined paper. Is that okay?
Yes, that's fine.
To do this earlier.
You on this class in here?